Hi and Assalamualaikum everyone. My friends and I are going to present about chapter 4, which is about atomic structure. There are actually about 4 subtopics that cover this chapter. First is about the Thomson's and Rutherford's model, then followed by the Bohr's model of the hydrogen atom. Next is about the Bohr's postulate and also about the radius of the Bohr's orbit. I'm going to explain about the Thomson's and Rutherford's model. Thomson's model is actually called as plum pudding model. It is roughly about 0.1 nanometer diameter. The Thomson's model is actually a homogeneous sphere of positively charged. The negatively charged or electrons also occupy the space to balance the positively charged to get a neutral atom. There are actually 3 persons that contribute to the Rutherford's model. First is the Anthony Henry Becquerel. He discovered form of rays emitted by uranium. Then J.J. Thomson discovered 2 types of rays emitted by the uranium, and he names them alpha and beta. The Ernest Rutherford then used the alpha ray to study the atom in gold foil experiment. Next, I'm going to explain about the gold foil experiment. There are actually a positive alpha beam directed at thin gold foil. Then the alpha particle deflected at the large angle. Referring to Thomson's model, alpha ray should slightly deflected. The spread out negative and positive charges forces almost cancel. However, concentrate positive at the center of atom enabling alpha beams to come close and then deflected due to the strong forces. The Rutherford's hypothesis states that atom consists of tiny positive nucleus at the middle. There are about 99.9% of atom mass is from the nucleus. Electrons move in the orbits around the nucleus. Nucleus diameter is around 10 to the power of negative 15 to 10 to the power of negative 14 meter. The Rutherford's model actually has its own weaknesses. The electrons emit continuous energy of radiation and orbiting the nucleus. However, the experiment shows the line spectra. Electrons spiral towards the nucleus because it's lost their energy during their moving around the nucleus. Then the atoms are not stable and will collapse. Therefore, the Rutherford's model failed to explain why atoms are stable. That's all from me. My another friends will present about the another 3 subtopics.
So my name is Muhammad Shami, and I'm going to presenting about chapter 4, continuing from subtopic 4.2. In previous subtopic, my friend Roshada said that Rutherford model have a weakness, which is the electron will spiral into the nucleus. So the electron and nucleus will be colliding, therefore the atom is not stable. And as we know, in 1905, Albert Einstein introduced quantization to the world, and in 1911, Danish physicist Niels Bohr, after receiving his philosophy doctor PhD, he joined Rutherford lab and continue studying about the atom. So Bohr, he found a solution to explain why atom is stable. So he add quantization in the Rutherford model. So this is the explanation. Electron will move in circular orbit, which is centered at nucleus, just like the Rutherford model, and there are enough centripetal force provided by electrostatic attraction. No, sorry, electrostatic attraction between nucleus and electron. I'm going to proceed with subtopic 4.3, which I will speak about Bohr's postulate. So there are three Bohr's postulate. The first one, the electron will stay in will move in the same orbit, and the electron will not radiating until it moves to another orbit, and the radiation will emit by the atom itself. So that was the first postulate. The second postulate, the frequency of radiation is related to the energies of the orbit. And the third one, the last one, electron only exists in specific orbits where states and angular momentum are quantized. That's all. Thank you.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Emna Syahda binti Manisam. So, for today, I'm going to continue the next topic, which is 4.6, which is the radius of the Bohr's orbit. As you can see, my fellow friends have been talk about the Thomson model, Rutherford models, the Bohr's model of the hydrogen atom, and Bohr's postulate. So I'm going to talk how to derive the radius of the Bohr orbit. So first, you have to know about the definition. So for the definition is, firstly, you have to know about the definition. So first, what's the definition of the Bohr's radius? So the Bohr's radius is a physical constant approximately equal to the most probable distance between the nucleus and the electron in a hydrogen atom in its ground state. So where did you get the Bohr's radius named? So actually, it's been named after Niels Bohr, which is gathered from the finding of the Bohr's model of an atom. So next, I'm going to show you how to derive an equation to find the Bohr's radius. Okay, here we have a hydrogen atom, and also the positive nucleus and the negative electron, and the electron is going around the nucleus, and this space at this point is where the velocity pointing in that direction. So now what we want to do is we have to find the Bohr's radius, the distance from the proton out the first ground state, which we call n1, and we're going to find the distance r, the Bohr's radius, and also we're going to do that by knowing that the positive charge and this is a negative charge, and that the force on those charges is equal in magnitude but opposite in direction. So in one cases we can say that electric force, and then in another cases we have electric force which we can calculate as a centripetal force, and those two forces have equal magnitude but point in opposite direction, and we're going to use that to now calculate the Bohr's radius, because we know the electric force can be calculated as a Coulomb constant. This is being Coulomb's law. Okay, so for this Coulomb's law, constants times one of the charge times the magnitude or the other charge is divided by the distance between them, then we can calculate the centripetal forces. I like to just start off with the Newton's second law. F equals to ma. If something is going in a circular orbit, then we know that acceleration is d squared over r. You can substitute that into this equation, then we can get this centripetal force as m, d squared divided by r, and we say that these two forces are equal in magnitude but opposite in direction. So I can set these two equations equal to each other, and we get that k times q1 q2 divided by r squared is equal to mv. So if you refer from the previous topic, from the Balmer series about the bars, you can get that L equal to mv, R equal to n h over 2 pi. This is come up from the bars. So from the equation that we get, there's equal we have that mvr, that angular momentum, for say it's quantized, is equal to this term nh divided by 2 pi. So now we're going to solve this term and these two terms, so we're going to substitute them into here. So v equal to nh over 2 pi mr. Now I'm going to substitute that in here. So as you can see, so we're going to substitute it first, then so we get ke squared over r equal to n squared mh squared over 4 pi squared m squared r squared. So from this we can cancel the m, and we also can cancel the r. So this is what we get, and we just gain the ke squared equal to n squared h squared over 4 pi squared m r. Then from this equation we going to, so we get the ke squared 4 pi squared mr equal to n squared h squared. So we get it r equal to n squared h squared, because we want to find the radius, so we have to take the everything from the left and just leave the r. Then ke squared 4 pi squared and m will be divided, and then we get the equation r equal to n squared h squared over ke squared 4 pi squared m. So now we can do the equation. So let's do. First we're going to find the n1. So r equal to, from the equation, so we just substitute 1 into n. As you can see, the how I substitute it. And then okay, the answer is 5.3 times 10 negative 11 meters. So that's how you find Bohr's radius, and I hope you understand what I'm trying to explain, and thank you for listening. Assalamualaikum warahmatullahi wabarakatuh.